Okay, tonight you're going to be learning 7-4, applying properties of similar triangles. Our objectives are use properties of similar triangles to find segment lengths, apply proportionality, and triangle angle bisector theorems. Okay, our first theorem here, triangle proportionality theorem. If a line parallel to a side of a triangle intersects the other two sides, so they're talking about line EF here, then it divides those sides proportionally. So what that's telling you is that AE over EB is equal to AF over FC. So find US. US, well, UV is a line that is parallel to ST because of the markings, and it intersects those other sides. So what we have here is we have RU over US equal to RV over VT. Then substitute in. RU is 14. US is what we're trying to solve for. RV is 10. And VT is 4. Do your cross product. Divide by 10. X equals 5.6. All right. Find PN. Well, PQ is a segment that is parallel to LM, so we can use the theorem, the proportionality theorem, and we can say that NP over PL equals NQ over QM, and then substitute in. This is what we're solving for. Do your cross product, divide by 2. All right, next theorem, converse of the triangle proportionality theorem. If a line divides two sides of a triangle proportionally, then it is parallel to the third side. So guys, what this is saying is if segment AE over EB is equal to AF over FC, then this line EF must be parallel to BC. So let's prove some of these. All right, so what we have here is BD over DA, and we're going to see if it is equal to CE over EA. So we have 15 over 10 equal to 12 over 8. And let's simplify, divide this by 5 and get 3 over 2. Divide this by 4 and get 3 over 2. All right, so they're proportional. Once they're proportional, we can say that DE is parallel to BC, and it's the converse triangle proportional theorem. Okay, two transversal proportionality theorem. If 3 or more parallel lines intersect two transversals, okay, so what we have here, even though they're not marked as parallel, but you've got AB, CD, EF, those are 3 parallel lines. Your transversal is AE and BF. Then they divide the transversals proportionally. So what that says is AC over CE is equal to BD over DF. So let's apply this one. Okay, suppose that an artist decided to make a larger sketch of the trees. In the figure, if AB is 4.5 inches, BC 2.6 inches, CD 4.1 inches, and KL is 4.9 inches, find LM and MN to the nearest tenth of an inch. Okay, so all of our units are already in inches, so all we need to do is set up. Okay, so we need to find LM. So what we can do is we can put KL over LM. KL corresponds to AB, and LM corresponds with BC, and then substitute in 4.9 over our X, 4.5 over 2.6. Do your cross product. So we're going to have 4.5x times this, divide by 4.5, and when you do that, you're going to get, let's see, round to the nearest tenth, so it's going to be approximately 2.8 inches. So LM is approximately 2.8 inches. Okay, now we got to find MN. MN, okay, so we can do many ways you can set it up. I'm going to put KL over MN equal to AB over CD. So KL is 4.9, MN is what we're trying to solve for, AB is 4.5, CD is 4.1. Do your cross product. Divide by 4.5. And you're going to get, let's see, this is, MN is going to be approximately 4.5 inches. Double check that. For some reason, I don't know if I did my calculation right. All right, last theorem for today's lesson. The previous theorems and corollary lead to the following conclusion. Triangle angle bisector theorem. An angle bisector of a triangle divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. Okay, so what this is saying is AD is the angle bisector of BAC because these angles here are congruent. Okay, since we know it's an angle bisector, it's letting us know that BD over CD is equal to BD corresponds with this angle, so that's AB. DC corresponds to this angle over AC. Okay, so let's apply this. Find PS and SR. Okay, let's do PS. So you have PS over angle bisector. Bisects this here, this segment. So you have PS over SR equal to, PS corresponds with this angle here, so equal to PQ. SR corresponds with this triangle here, so that's QR. And then we can substitute in. PS is X minus 2. SR is X plus 5. QR is 32. Excuse me, that's PQ. And QR is 40. Okay. Do your cross product. So we have 40 times X minus 2 equals 32 times x plus 5. All right, we need to distribute. So we have 40x minus 80 equals 32x plus, what is that, 160? All right, we're going to add 80 to both sides. So I have 40x equals 32x plus 240. I'm going to subtract 32 from both sides. When I do that, I have 8x equals 240. And then I can divide both sides by 8. Therefore, x equals 30. That's not what we're solving for. We're solving for PS. PS equals x minus 2. So that's 30 minus 2, which equals 28. And then SR is x plus 5, so that's 30 plus 5, which is 35. So here's your final answer. And that's it for 7-4. Have a good one, guys.